Hello, my name is Marcus Agun, and this is Lab 1 of Physics 2212. All right, the purpose of this lab is to determine the amount of charge on a charged piece of tape. For this, we'll be using physics concepts such as electric fields and electric force. And the main objective of this lab is to see how modeling the charged pieces of tape as point charges versus line charges will affect our results. So the physics principles, first we'll have electric field, right? So that's just how a charged thing interacts with the stuff around it, right? Electric force is just going to be if you have another charged particle, it's going to be that charged particle times the electric field of whatever's around it, and that's going to be the electric force on that particle. Then we'll have gravitational force, just force pulling you downwards, right? That's just going to be negative mass times the gravitational constant, which is 9.81. And then we're gonna have superposition, right? So superposition is basically if you have a bunch of electric fields and you want to see what the net electric field is at a certain point, then you just add up all the electric fields that are around it, and you just get the vector sum of that, and that's gonna be the net electric field. And then we have equilibrium, right? So we're gonna have one tape on top of the other. So this basically just means that the negative of gravity is going to be equal to electric field. All right, so for this experiment, it was conducted by treating two charged pieces of tape, and then I put one tape on these cups, and I held the other tape on top, and then the tape on top, since these are both like charges, the tape on top was repelled a certain distance, right? And then I used a tracker to figure out the distance that it was repelled through a video, and I used the height of the cups to calibrate the tracker. All right, so for the first part of the coding, we just model the tapes as point charges and figure out the amount of charge on a piece of tape. So first the length of the piece of tape was 0.152 meters, and the mass of the tape is just 0.000152 kilograms. The distance from the distance that it moved from the lower piece of tape was 0.0307 meters. The gravitational force is just the mass of the tape times 9.81, which was this. And then since they're in equilibrium, the electric force is just going to be the negative of the gravitational force, so they're going to have the same magnitude, right? And then after that, we just manipulate the E field equation to figure out what the Q is, the charge. And we got the charge is 1.2496 times 10 to the negative 8. All right. And then in coding part 2, we used our results from part 1, and then we modeled the tape as a line charge instead of a point charge, right? So first we get the electric field of our point charge, and then we sort of break it up into smaller pieces, right? So we break it up into smaller pieces, and then we use superposition to figure out the what's called net electric field at at our observation point, and then we multiply by Q to get our final magnitude of electric force, right? So this part right here is this is adding up, or this is breaking down and adding up all the smaller pieces of the tape to eventually add up to our net electric field at a certain point. And we can see that the charge is actually greater than what we predicted with the point charge, and the magnitude of electric force is also 3.23 times 10 to the negative 4. So with both our first coding and our second coding, we do use Q as a point charge, right? We do break it up in our second coding, but we still do use our result from our first coding, which modeled our Q as a point charge. So also the charges on both pieces of tapes aren't necessarily equal, right? But we kind of assumed we do throughout the experiment. And then also the weight of the tape is estimated. I didn't use a scale. I just calculated it using the thing. And if electrons were positive instead of negative, it still wouldn't change how or it wouldn't change the things that we observed, because since both pieces of tape were charged, and then charges repel, if they were both positively charged instead of negatively charged, they're still going to repel, so it would still end up being the same. And the point charge and line charge models are different because the line charge model it accounts for larger surface area of charge versus a point charge model, which is just a single point. So they end up being a little bit different. But the line charge model is more accurate because the tapes are more like lines than they are points. And yeah, that's the end of my stuff.